Hello again and welcome to the performance section of this build, where adding power in any manner is key. To add power to an engine requires many things, the prime one being an unlimited budget, titanium parts, professional tools, and a powerful computer that can handle software such as finite element analysis, which in this case I have none of what is mentioned. Now, being so restricted with money and resources, I'm stuck with whatever I can recycle. So let's concentrate on what we have here. And that is a series of damaged, roughly built and tired parts. The problem I constantly noticed ever since my father bought this car was an absurd amount of engine heat coming from the engine bay, the kind that you feel a rush of heat leaking between the head and the exhaust manifold, so one could easily tell the engine was screaming for help. But at the time, I wasn't allowed nor skilled enough to address this issue. The cast iron type manifold is a heavy one, however it can withstand an absurd amount of heat when compared with stainless steel manifolds. So in a way it does have some positive attributes to it. Now, these manifolds have undergone all types of stresses and corrosion due to the constant change in temperature and exhibiting extreme heat. So it is very clear of how much the faces have corroded, and how obvious it is that it leaked from everywhere. So that was the reason why I felt all the heat emitting from the engine. The improvement that will be done to this manifold is to transform the passages from being small, uneven and filled with sandcasting defects to increasing the bore of each port to match the maximum allowable diameter of the exhaust gasket. Now, the goal of this process is not only to increase the bore, but to smooth it as much as possible. So the carbon deposits will not gather in the manifold and decrease the efficiency of the turbo. I've tried to go as deep as my limited tools permit me to. So the overall improvement of the standard manifold was around half of what the ideal manifold would achieve. Yes, when polishing such cruddy parts, unexpected hidden problems will surface, such as cracks. Now, I wasn't surprised to find this kind of damage since the car was so badly maintained by many overrated specialists that call such problems no big deal and do nothing about it. However, exhaust parts, especially the manifold and turbo housings, are still prone to cracking due to subduing extraordinary temperatures, and an example would be when driving on a rainy day, the material will be subjected to constant heating and cooling, which would definitely crack the material if the change in temperature would be dramatic. Well, in this case, I will have these cracks re-welded and all the surfaces polished again, because I'm obsessed with having these little hidden details taken care of. Also, it doesn't hurt to have a nice exterior finish. So as seen here, the faces have been machine polished and the bores neatly finished as much as possibly allowed. The original turbo wastegate housing has been changed because originally where the wastegate sits was correct. Thus, this would lead to turbo boost pressure leaks. Now, these parts are extremely hard to find, and when found, they were ridiculously expensive. The next thing to do is to repair the crack at the collector and finish it off by evening off the faces. Now, in an extremely summarized explanation for the process of cast iron, the standard cast iron manifold comes riddled with faults, such as uneven shapes and possibly defects within the steel when it was initially casted. This is usually referred to as porosity, which is when you have trapped air bubbles in the metal. The cast iron will most likely have inclusions in it and undergo fatigue, which will affect the strength of the material. And the heat or change in heat will most likely cause the metal to crack. Here we can see the defects from when it was initially casted. It is clear to see how the sand casting process took shape, thus forming these staggered shapes. So here's the difference from a ported manifold to a standard setup. However, upon closer inspection, some of the defects in the material will tend to surface, as seen on the left side. And here on the top side, the defects with regards to porosity is very visible. So the only solution is to keep grinding away and polish dangerously close to the limit. But at the end of it all, it only gets really scary when it reaches the limit of the tolerance and the gasket coverage. The faces have been machined, but as you can see, the result was not to my liking and thus was further polished to perfection. This is the result of what happens when the metal undergoes fracture toughness due to being subdued to extreme heat. The complicated side of this port grinding section is that everything has to be done manually. Since the only tool I have and could afford is a 900 watt driller, some grinding stones and sandpaper. So, as a result, I'm never gonna have a perfect diamond cut finish. Now for the air to exit from a restricted and very badly finished manifold will cause an unstable vortex. So the basic principles of air exiting the engine comes out and pulses. And as the air exits, it also tends to spin. So when it has uneven patterns and brushes against a lot of obstacles, it will create back pressure, because the air will tend to take a bit longer to exit and creates more friction as it exits, and friction, as we know, generates more heat. So when polishing and increasing the port size, it will increase the volume and reduce its drag when the air is exiting. Thus, it will automatically increase the overall engine efficiency. However, the only downside to it is that it will also affect the fuel economy. But who cares when you're spooling more turbo boost? Back to the actual work on the manifold. That is an example of a polished bore. These are the typical cracks found at the collector. And this is a typical before and after. Here are the initial rough stages of port grinding, trying to eliminate the imperfections. And this is the typical amount of dust created from just the initial grinding. So now with larger bores we are starting to see a clearer picture of all the improvement. So basically, from here onwards, it was over 100 hours just in grinding, and a good enough result emerged. So from here on, I could continue onwards to the next stage and rebuilding the turbos, but that is for next time. So see you then, and thanks for watching.